For as long as man has walked the earth, he has looked up to the skies and wondered, what lies out there, and what is our place within it? We can now peer out across the universe to the very limits of time and space. From stars seething with violence to a terrible dark abyss, the black hole. Written in the night sky are the great questions of our existence. How did the universe come into being? Where does it begin and end? Are we alone? And so we now journey into the unknown to explore strange and distant horizons. As Reader's Digest presents Mysteries of Deep Space. For centuries, we saw ourselves at the center of an unchanging universe. The stars overhead were fixed, eternal. As for what lay beyond, we had little idea. Then, 400 years ago, Galileo invented the telescope. Gazing into the darkness, he came to a startling realization. The heavens are much bigger than we ever dreamed. And they are not static at all, but restless, relentless, churning with activity. Galileo's discovery was just the first of many, as the science of astronomy was born. Today, it is being reinvented all over again. A remarkable series of advances has opened the door to revolutionary breakthroughs. A new generation of technology, a new age of discovery. On mountaintops around the world, astronomers are building ever larger telescopes, capturing light from ever more distant reaches of the universe. In 1990, in the most far-reaching development yet, scientists literally raised astronomy to a whole new level. The Hubble Space Telescope was placed in orbit 200 miles above Earth. Beyond the distorting effects of the atmosphere, it was designed to produce images 100 times sharper than the best telescopes on the ground. It was a mechanical marvel, but the dream nearly died. Astronomers were shocked and disappointed when Hubble began sending back blurry images. Its mirror had a flaw. The largest investment ever in astronomy, nearly $2 billion, seemed lost in space. 3 years later, astronauts returned to Hubble's side. The nation looked on as they undertook painstaking repairs against seemingly impossible odds. But within weeks, their success was clear. The world was amazed as the telescope sent back a series of incredible images, like these, with color so vivid, details so sharp and realistic. Here were realms never before glimpsed, events never before witnessed, pictures of stars born, stars dying in the spectacular light show of the skies. Hubble has orbited the Earth more than 50,000 times and taken more than 120,000 pictures. All across the planet, the Space Telescope has inspired millions to look at the cosmos in a brand new way.
Yes!
Among the most enthusiastic are a group of amateur astronomers who gather each spring in West Texas. The Texas Star Party takes place under night skies as dark as any in the United States. Up to 700 stargazers arrive from around the country to roll out their telescopes. They may be amateurs, but their equipment is anything but. They come geared with precision mirrors and equatorial fork mounts, sophisticated computers and star tracking software. The sky's the limit.
There's a lot of things out there that people never realize are out there. Just seeing these points up in the sky that don't really mean anything except they're just white dots. But there are all kinds of things out there that are just unbelievable to see.
As night approaches, 1,000 eyes turn to the sky. For amateur and professional astronomers around the world, the lights overhead are a call to journey, to search for our own place within the universe. And what they are finding is that our home, our Earth, is a tiny world indeed. It is one of 9 planets orbiting a sun. A star in a galaxy called the Milky Way. Our galaxy contains 100 billion stars. It is so vast it would take 1,000 lifetimes traveling at the speed of light just to cross it. And ours is only one of 50 billion galaxies in the universe. At its center is an immense glowing dome that is densely packed with stars. Yet if you could hold our galaxy in your hands, it would be as thin as a sheet of paper. Within our universe, astronomers have shown us an amazing cast of cosmic characters. From giant galaxies to dwarf stars. From quasars to comets, those churning missiles of rock and ice. And they have given us a glimpse of its darker side. Places where stars, even whole galaxies, are swallowed into a black hole. Our telescopes have taken us all the way out to the edge of the universe, to the edge of space and time as we know it. And they've unveiled a cosmic drama of birth and destruction. One of the key figures in this drama is something remarkable. A cataclysm visible across the depths of space. A supernova. It is literally the death of a sun. A fiery blast in which a star blows itself to smithereens. But these are not just fires of destruction. These are the fires of creation. For in the death of a star, the universe is reborn. The eruption of a supernova actually seeds a galaxy with the chemicals that make new planets, indeed life itself, possible.
Supernovae are the grandest explosions in the present universe. They put out in a period of 10 seconds as much energy as all of the stars and galaxies and quasars in the rest of the observable universe put together. And the energy is not just a great fireworks display, it also gives rise to a shock wave that propagates through the star, and the conditions in that shock wave give rise to a lot of the elements of which planets and you and I are created.
Throughout our history, we have looked in fascination at the few exploding stars bright enough to see with the naked eye. In the year 1054, Native Americans used rock paintings to record a supernova near a crescent moon. Astronomical scrolls in China, Korea, and the Middle East recorded the same event. The Dutch astronomer Tycho Brahe saw another supernova in the year 1572. He wrote, "I was led into such perplexity by the unbelievability of the thing that I began to doubt the faith of my own eyes." Galileo recorded the next one in 1604 in the constellation Serpens. It would be nearly 400 years before another so bright was spotted. Observers in the southern hemisphere were astonished by its appearance in a dwarf galaxy just beyond our Milky Way in 1987. More than a decade later, its light has faded. But the Hubble Space Telescope continues to track its progress. Here we can see ultraviolet rays bursting from the supernova have caused surrounding clouds of gas to glow like giant fluorescent rings. Today, astronomers are scanning the skies night after night, hoping to spot the next big one. Supernovas only come along once a century in most galaxies. If you had to bet on who will see it, you might look to this man, Robert Evans, a world-famous supernova hunter. Not a professional, but an amateur working from his own backyard. On the side of his telescope, he's chalked up the locations and dates of his discoveries, like notches on a gunfighter's belt. He has spotted 37 exploding stars, more than any other amateur astronomer on Earth. His grasp of the universe is prodigious, but his motto is simple: seek and ye shall find. Evans isn't only an astronomer. He's also a pastor for churches near the town of Coonabarabran, Australia.
The Lord bless you and keep you. The Lord make his face to shine on you.
By day, he preaches the Bible's great story of creation. By night, he explores its ongoing drama.
Now and forevermore. Amen.
For the story of a supernova is, in its own way, the next step in the story of creation. Every time a supernova explodes, it sets in motion a chain of events. Debris flies out and new pieces of the universe are created. Among the most remarkable of all, the birth of a new star. You can see it happening along the edge of the Pinwheel Galaxy, 50 million light years from Earth. The Hubble Space Telescope zeroed in on a massive cloud of gas. It is in fact a hatchery of stars. In places like this, shock waves from a supernova cause the gas to condense into a ball, then ignite. And stars are born, sometimes hundreds at a time. In these rare pictures, Hubble captured up close the violent first moments of star birth. As matter rushes into the infant star, it spews out high-speed jets of radiation. They burst forth like machine gun rounds. The Eagle Nebula is one of the great star nurseries in our home galaxy. Intense winds have sculpted a majestic castle of gas. Inside these giant columns, matter is being drawn together and shaped into stars. But just beyond the neighborhood of our sun, we can see something even more incredible: the birth of a solar system. This immense cloud is the Great Orion Nebula. Veiled within lies something astonishing. Vast platters of dust and gas encircle fully half the young suns. What you are seeing is not just stars. These are entire solar systems like our own in the making. In some, gravity will concentrate the dust, drawing it together to form asteroids and comets, planets and moons. These new solar systems are fertile places. Over time, supernovas have seeded their surroundings with carbon, oxygen, iron, the ingredients not just for planets, but for life itself.
I study exploding stars partly because I find the concept that atoms in my body were cooked up inside stars, and especially inside exploding stars. I find that concept to be completely mind-blowing, and I'd like to understand the process by which this occurs in the universe. Really, we're studying our own origins at a very fundamental level.
Scientists around the world are combing the distant skies for supernovas, because each one offers clues to the beginning and the ending of our solar system. Astronomers are hoping to gain glimpses of how these mighty explosions might have shaped our planet eons ago. They've come to the Keck Observatory on Hawaii's Mauna Kea volcano, one of the world's largest and most advanced telescopes.
If all we have is half a night, knock off everything that we can see in half a night. And then
Saul Perlmutter and Alex Filipenko are looking for a breed of small stars that have reached the end of the line. This is the fate that awaits our sun in about 4 billion years. Like many small stars, it will not go supernova. Instead, it will begin to swell, becoming a red giant. Planets like Earth will be swallowed and incinerated. In time comes the next step. As this Hubble image of a similar star shows, it convulses in a fit of violence and sheds its outer layers. This image of the famed Helix Nebula in our galaxy shows a still later stage. A ring of expanding gas forms. A powerful wind still blowing from the star shapes a great halo. And here is what the dying star eventually becomes. It is called a white dwarf, the glowing center of these images. It is now the size of Earth, 1/1,000,000th what it once was. There's only one way a white dwarf could ever become a supernova: if it orbits another star. Because of its intense gravity, the white dwarf begins to suck gas from its companion. Its own mass finally reaches a critical limit. It blows itself up in a violent conflagration.
We're completely destroyed.
With good viewing conditions overhead, this is exactly what the astronomers are looking for. And they're going for a record: the most distant supernova ever spotted.
There it is.
That's
It
nice.
is. It's a supernova. Look at all the undulations.
Yep.
We got another one. Oh man, this is like shooting fish in a barrel, you know? Oh, fantastic. This is an easy one, and clearly this.
The team will compare their distant supernovas to nearby ones to understand how the chemical makeup of stars in our galaxy changed over the eons.
Deep down
Yeah, well,
inside,
if you look at the pictures here,
the reason many of us are scientists is to experience the thrill of discovery. To sit there one night observing and to come to a realization that you're the first person in the world to have understood that particular phenomenon. There's something really gripping about that. Okay, there's H and K. Yeah, let's see what it'll turn. Looks pretty high to me.
Okay, that's
Wow.
65,
So let's
59,
see what this gives us.
0.65.
0.65.
right.
Hot dog. The other calcium line gives the same redshift, so we've got a new record.
The explosion they've witnessed occurred some 5 billion light years away.
yeah,
It's the most distant supernova ever seen,
that's good. You
Okay.
see the wiggles.
and its traces are still rippling outward to us, halfway across the universe.
These are the most powerful explosions we know of in the universe, aside from the creation of the universe itself, the Big Bang. Besides being exciting, the power of the explosions makes these objects visible at very great distances.
The most personal thing that I have taken out of this is this incredible sense of belonging, of having one great river of time, from the birth of the universe, the formation of galaxies, which made possible the formation of stars, cooked heavy elements, supernovae that shed heavy elements like carbon and oxygen into the interstellar medium, later swept up into the solar system, makes planet Earth, makes organic matter, makes human beings, makes me. It's one very beautifully integrated story from beginning to end.
To stargazers around the globe, the universe reveals its restless ways. Just in time, the star party is now in full swing, and the passion for the stars starts early. Tonight, a father unveils a telescope he has built for his 10-year-old son. It may not be up on a high mountain or out in space, but for a young stargazer, it's state-of-the-art.
Say right up here.
Yeah.
All right. Here you go. And just push in. Got it. You want to look at Venus first?
Yeah, where is
Since
it?
it's up?
Oh, there it is.
It's
over
right there.
Oh, wow.
An astronomer is born.
Astronomically.
This family has years of stargazing ahead of it,
It's a rainbow, all right.
but tonight will be hard to beat, even for all the veterans who have come to witness the spectacle of creation.
When I see gas clouds, I see these little globules of stuff up there. What I think of is, you know, I'm seeing something forming. I'm seeing something being created. It's exciting.
Sometimes very mysterious to people and very frightening. And I know the Lord put things up there for us to see and to behold the beauty in it. And you can come out here at night and the ground is lit, that you can see your shadow and you can walk around. And you can look up and watch the meteorites as they come in and just watch the heavens as they turn, which is a wonderful thing.
Where are you going, Jimmy? You want to see the light?
Tonight, even a 2-year-old is starstruck, though her technique could use a little work.
What do you think? Did you see it? I doubt it, but you could try. You want to try again?
By the time she reaches her father's age, who knows what visions of the heavens will await her.
Pretty cool. Jenny wants to get in on it too.
There is so much more to learn. As we peer into the night sky that turns above us, we can only imagine what lies beyond our earthly horizons. Astronomers have now brought us to the brink of what will no doubt be one of the most startling revelations in our history. That among the stars, we are not alone. That something or someone else is out there. And so we set off on the next step of our journey, the search for alien worlds. For eons, we have locked our gaze on the stars, awaiting some glimmer of other life. We have looked into the vastness of space and wondered. In our galaxy alone, there are an estimated 500 billion planets. Among all these worlds, are there planets like our own? Are there beings like us? Who or what is waiting for us out there? Popular movies have conjured aliens, visitors from the great beyond. But all the while, scientists have been working, looking for signs of distant planets.
Okay, Wayne, roll them. 51 peg.
They are scouring our solar system, sending out probes to hunt for evidence of life. No one knows if alien life does exist, but the odds are that it does. At least that's the view of one group of scientists who firmly believe that advanced civilizations are even now trying to contact us with radio signals. All we have to do is put our ears to the cosmic rail and listen. It's called SETI, which stands for the Search for Extraterrestrial Intelligence.
This is not just another piece of science, as interesting as that may be. This really hits at the gut level. Are we alone? Are there other creatures? What do they look like? How do they act? How do they deal with their environment? Are they going to come visit? What can they tell us?
Earth is routinely barraged by a shower of radio waves, generated by myriad natural sources throughout the cosmos. What SETI is listening for is a distinctive, repeated signal that could only be produced deliberately. During the quarter century that SETI has been tuning in, there have been a handful of tantalizing receptions. Its supporters are willing to wait decades for a sure sign of intelligent life. In fact, the search for aliens has been on our minds for many years now. The 17th century astronomer Johannes Kepler imagined that intelligent creatures had constructed dwellings on the sides of moon craters. In 1835, a newspaper announced that a noted astronomer had glimpsed astonishing details of moon creatures. They were the Selenites, a civilization of lunar man-bats. If anything, the great moon hoax only fueled the appetite for aliens. Astronomers and dreamers alike turned to the nearest planet, the red planet, Mars. To early civilizations, its color had evoked blood, fire, and war. The Romans named it for their god of battle. At the end of the 19th century, the Italian astronomer Giovanni Schiaparelli noted something else: markings running down the planet. On closer examination, he saw lattices of double lines. He speculated that they were canals, carrying melting snow from the poles to the dry interior. For one astronomer, Percival Lowell, the lure of these features was irresistible. He commissioned a new telescope to study the Martian landscape for himself. Lowell not only saw the canals, he found twice as many. He came to a dramatic conclusion. They were traces of a sophisticated society intent on shaping its environment on the grandest of scales. With an impassioned series of best-selling books, Lowell pitched his vision of Mars to an eager public. A fierce debate began to rage, and all the while Mars gripped the popular imagination. Who were these Martians who had mastered the elements through engineering? They must have evolved far beyond the human. They had large heads, barrel chests, and long snouts, all due to their planet's reduced gravity and thin atmosphere. Mars was alluring, and it sold soap. Schemes for making contact abounded. Giant mirrors flashing greetings, light beams, interplanetary calls, or even mental telepathy. Perhaps, said one French astronomer, an ancient race of Martians had been signaling us since the age of the dinosaur. They simply got tired of trying. Another maverick believed it wasn't too late. We could still receive messages from Mars. In 1924, the astronomer David Todd convinced the U.S. Armed Forces to suspend communications for an unprecedented 3-day period. As Mars approached its closest orbit to Earth, all ears were tuned in. Speculation abounded, but there was only silence. Then the aliens appeared.
What's that? Some sort of a war tank. They're not human!
What did they want from us and our planet? In the years that followed, motion pictures enacted the moment of contact when aliens would step onto our soil. They came to take control of our world.
You will find that conquering the Earth isn't so simple.
This is our planet, Astron Delta.
They sought haven from a hostile universe.
During the 23rd time rotation, our sun began to die. Our eyes developed to this state to combat the ever-growing darkness.
They would stop at nothing to recover resources lost in a cataclysmic war. Resources like men.
Who are you? My name is Naya. I will select some of your strongest men to return with me to Mars.
And if they don't want to go with you?
There is no if.
In the 1950s, scientists began to envision a day when astronauts would actually venture to Mars to explore it. They still saw the planet as Lowell did, a place with running water and sparse vegetation. Then in 1964, the Mariner 4 mission sent back the first close-up images of the Martian surface. Lowell's canals were not the product of nature or Martians, but of his fertile imagination. They simply didn't exist. But while Mars was barren, there was still the possibility that some form of life dwelled there. If not two-headed Martians, then at least some cells or microbes. In the 1970s, the Viking mission landed 2 probes on the planet's surface to look for chemical traces. The probes spent months scooping and analyzing Martian dirt. In the end, they failed to find any evidence of life. At Earth's doorstep, it seems, creation has placed a lifeless desert. But today, scientists are looking at Mars anew. Mars may be lifeless now, but that doesn't mean it always was. Once the planet was warm and wet like Earth, then its atmosphere thinned, and it plunged into a deep ice age. The surface of Mars has remained frozen in time. For billions of years, the planet's thick crust has prevented the welling up of molten rock from its core. What Mars lacks is the volcanic activity that has long replenished our atmosphere and circulated water from below. Did Mars harbor life long ago? Scientists are trying to find out by studying another harsh corner of the solar system. Mono Lake, California. On the eastern side of the Sierra Nevada mountains, this is an otherworldly realm all its own. A place that resembles Mars in several surprising ways. NASA exobiologists Jack and Maria Farmer are setting out to discover how life might have arisen on Mars. Encased in Mono Lake's rock formations are primitive organisms that billions of years ago were among the first life forms on our planet. It may be that similar organisms developed on Martian lake beds when that planet was young.
During this early period in Mars history, there was a constant rain of organic molecules onto the surface being delivered by comets, by interplanetary dust particles, and so on. And at the same time that was happening, we also know we had liquid water available at the surface. Life could have originated on Mars because we had all the basic ingredients: liquid water, all the organic chemicals, and enough time.
The remains of tiny microbes can be seen here within layers of minerals. It's fossils like these that NASA hopes to find on Mars. And as it turns out, we may already have examples right here on Earth. 3 billion years ago, scientists say, chunks of Mars' surface were sent hurtling into space. One wandered through our solar system till Earth's gravity finally drew it in. A group of NASA scientists concluded that the rock from Mars bears markings that may indicate the presence of ancient microbes. In other words, extraterrestrial life. This finding has since come under heavy attack. But that hasn't dampened our curiosity.
T-minus 5, 4, 3, main engine start, 1, 0, and liftoff of the Delta rocket with Mars Pathfinder.
On the trail of alien life, we are now venturing back to Mars. A spacecraft called Pathfinder began a 7-month journey to renew the search. July 4th, 1997. As Pathfinder makes its final approach to the red planet, the world tunes in to witness the historic event. These are anxious moments for those who've poured their heart and soul into the mission.
Sammy, do you have an offset for that?
That's a very good sign, everybody.
I believe I have a firm signal.
And then, the word they've all been waiting for. Pathfinder has landed. Shortly after, the first pictures from Mars. A brand new age of exploration has begun.
Stan, your pictures are up there, man.
These are actual images from the Martian surface, and the story they tell is amazing. Pathfinder's cameras reveal a landscape filled with telltale features. Features surprisingly like Earth. The ground is littered with evidence that Mars was once active. Rocks ejected from volcanoes, boulders scoured by water, Most startling of all are two distant hills known as Twin Peaks, for they were islands left standing in a raging river. A Pathfinder rover exploring the terrain found dust everywhere, probably deposited by ancient rivers. For billions of years, winds have moved it about like the shifting sands of a desert. It now appears that Mars did indeed once meet the conditions for life, and our search may only be scratching the surface. If there is water deep underground, living microbes might still flourish there. The only way to find out is to dig for them. Of course, Mars may not be the only place in our solar system to look. The conditions of life may also exist on one of 16 moons orbiting the planet Jupiter, known as Europa. Beneath Europa's crust, scientists believe is not just water, but an entire ocean. Just the kind of environment that can spawn microbes. The gravity of Jupiter twists the interior of Europa as it orbits, generating heat in its core. The turbulence below is written across a veneer of ice. Scientists believe warm water rises to Europa's surface, splitting the icy crust and producing vast fissures. In the future, they hope to send a probe to Europa to dig below the ice and find out whether primitive creatures could possibly inhabit this dark ocean. All around the world, the race is on to find the first signs of alien life. And the hunt is not confined to our solar system, to the planets we know. It is making remarkable strides in the galaxy beyond. For the past decade, two astronomers have been peering into the universe for clues that might reveal another solar system.
If we had to give a talk tomorrow on giant planets, those four stars would be the ones we'd be talking about.
Paul Butler and Jeff Marcy are planet hunters who have pioneered a technique designed to detect the presence of other worlds. And they're not the only ones looking. The Swiss team of Michel Mayor and Didier Queloz have discovered the very first planet ever spotted outside our solar system. The news made headlines around the world.
And so we went to the telescope.
Marcy and Butler confirmed the Swiss finding. It's an exciting first step, but don't expect to find life there. It is a giant planet, even larger than Jupiter. Yet it's so close to its star that its atmosphere is heated to a sizzling 2,000 degrees. The parent star, 51 Pegasi, is as bright as our own sun, so bright that planet hunters can't see through its glare. Still, there is one way they can be sure a planet's there, by studying the effects of its gravity.
Okay, Wayne, roll on 51 Peg.
Okay. Starting the exposure. Well, you can think of it this way. Our sun sits like a giant bowling ball, and the biggest planet in our solar system, Jupiter, is 1/1000th of the mass of our sun. So when Jupiter goes around, it barely moves the sun around. So our sun is an almost immovable rock in the face of Jupiter. But the sun does move a little bit, and here's how fast. The sun moves about 12 meters per second, which is about the same speed as the fastest Olympic sprinters. So our sun is in effect sprinting around in a little circle due to the pull of Jupiter. Yeah. Standing. That's one.
Marcy and Butler's readings are so precise, they can detect the tiniest gravitational wobble. What they are hoping to find is a more complex wobble, a sign not just of one planet, but many. As they go through 8 years of data, the prospect of actually discovering another solar system is getting closer.
There's something really wacky going on in this system. It's happening wacky literally on periods of days or weeks, but then over many years you've got this wild trend going on. So this could be the first authentic, real live solar system that's detected. We won't really know until we get another year or two of observations, but we're real close.
The question is, are there other planetary systems which have a planet somewhere in that system which has the characteristics which make life possible? Liquid water, primarily.
On the hunt for life, there are telltale signs. Scientists look for a planet that's not too hot and not too cold, one with a stable circular orbit, an atmosphere with oxygen and carbon dioxide, and above all, water. A place that sits squarely in what scientists call the life zone. A place, in short, just like Earth. We may be on the verge of finding such a place.
Two San Francisco State University astronomers say they've discovered yet another planet outside our solar system, circling a star some 40 light years from Earth.
The discoveries are coming at a rapid rate.
We live in a solar system ourselves, and we know that life...
Success. In a string of announcements, Jeff Marcy and Paul Butler unveiled the discovery of a whole series of new planets around nearby stars. But are these worlds like our own? Planets in the life zone? Marcy and Butler are beginning to get some answers.
The one around 47 Ursa Majoris is a planet of about 2 Jupiter masses. If you put that planet in our solar system at the right distance, you'd say, gee, that looks like a normal planet. On the other hand, we are seeing other planets around these other stars that really look very, very different. Some of the planets are in too close. We have 2 planets that are extraordinarily close to their star. And we have 2 planets that are in orbits that are non-circular, very eccentric, elongated orbits. And we don't see planets like that in our solar system.
One nearby star, called 55 Cancri, has a planet the size of Jupiter, but sits so close to its sun, it circles around it every 15 days. Another planet orbiting the star 70 Virginis is 6 times heavier than Jupiter. Its path takes it drastically close to its star, then swings it out wide. Scientists wonder what forces conspire to shape these strange orbits. The answer, they believe, is that some solar systems contain 2 large planets, close enough to fall under each other's gravitational spell. They're using supercomputers to see how these giants interact. Each time the pair passes, their mutual gravity tugs them gradually out of orbit. Inevitably, they cross paths. One planet is flung to the outer reaches of the solar system. The other hurtles toward its sun, where it is captured in a close orbit. A smaller planet, the size of Earth, thrown out of its circular orbit, would have little hope of sustaining life. Researchers believe they may have spotted a giant planet jarred from its orbit in just such a way. Hurled beyond its star, it was left to drift in the frigid void. This Hubble image could be the first picture of a planet beyond our solar system.
We are finding planets that completely defy our prior conceptions as to how planets would have formed. And that's the glory of science. We can reject, in part, some of the notions that were too narrow about how planets form, and we can now embrace a much wider range of processes that lead to planets.
What other kinds of solar systems will we find in our galaxy? And could any support life? These questions will fall to the next generation of planet hunters. Early in the 21st century, NASA plans to launch the ultimate planet hunter into orbit around the Sun at a distance beyond Mars. Known as an interferometer, it is a series of mirrors arranged along a line that combine their signals into one. This is a new breed of telescope, complete with infrared detectors that can read light reflected off the surface of planets. It will send back a whole new series of clues, indicators to tell us if there could be life out there.
At first, it would just be a dot. Then you can take that dot of light and spread it out into all of its colors, blue through red, even into the infrared, and with that spectrum of colors, detect the chemicals that are making up the atmosphere of that planet. By detecting the chemicals, we can look for oxygen, methane, CO2, and so on, and those chemicals will be the signatures of life, if it exists, on those Earth-like planets.
Until we find those signatures, we will wonder whether life resides on our planet alone.
Now that we're realizing there are planets out there and that there may be life out there, I think the galaxy is beginning to seem like something of a romantic place again, a place where there might be other intelligences and beings out there, perhaps something like ourselves, beings that we could communicate with over the centuries to come.
As we look out into space, we are like an only child. We wish we had company. Still, we take pride in being creation's one and only. And so we continue to search for our place in the universe, reaching out across the infinite expanse, wondering, waiting, watching the cosmic horizon.
We've seen ourselves as alone in this enormous universe in which the distances are so great that they boggle our minds. And yet, if we could only find life in other places, we'd realize that we belong with them, that all together we make up something that the universe was calling forth because it needed it.
We have come so far in our search for alien worlds, and still we have so far to go, so far to travel. For to understand the scope of creation, we must confront the cosmos at its most violent, its most destructive. And so as we continue to probe the mysteries of deep space, our journey takes us to the dark side of the universe, to the ultimate abyss. Black holes. In the far reaches of the universe are places where time and space cease to exist, where matter itself is changed beyond recognition, in a strange and forbidding chasm called a black hole. It is a void, yet a fiery realm of destruction. A place where a star, a solar system, even an entire galaxy can be sucked in and compressed down to a point smaller than a speck of dust. For centuries, scientists debated whether black holes could even exist, until now. They are finally beginning to learn how our universe can craft a black hole from a shining star. It all starts with a battle every star must wage against gravity.
Stars spend their entire life fighting gravity. If there would be no other force, gravity would pull all parts of the star and make it collapse to a point. What the star manages to do is to ignite nuclear reactions at the center of the star, which cause a very high temperature and high pressure. And this pressure gives an outwards force which holds the star against gravity. So only as long as the star has this nuclear energy available, it can really hold against gravity.
But when the star loses the battle, as all stars eventually must, it sets in motion a chain of destruction and decay. A small star like our Sun can keep the inward pull of gravity in check and burn for billions of years. It eventually fizzles out, like these captured by the Hubble Space Telescope. After spinning off their outer layers, all that's left is a tiny dense star called a white dwarf. But the death of a large star is not nearly so peaceful. This picture shows a giant known as Eta Carinae, nearly 100 times the mass of our Sun. Over a century ago, it convulsed in a fit of violence. This animation shows what might have shaped the explosion. Eta Carinae swallowed another star. As the victim spiraled inward, it caused the giant to spin faster and faster. The larger star began to throw mass out its equator, then to fling huge clouds of gas out its poles. The Hubble Space Telescope found that these fiery lobes are roaring outward at a rate of 1.5 million miles per hour. This giant is the brightest star ever spotted in our galaxy. Stars like this burn hot and fast, and as they do, they fuse light elements into denser and denser ones. The star grows heavy until at last it collapses. This computer simulation shows exactly what happens to the star on its road to oblivion. As matter rushes inward, it releases energy that heats the star from the inside out to billions of degrees. A pressure wave rushes outward, and the star erupts into a supernova. It is an explosion of unimaginable power and ferocity. As spectacular as a supernova may be, there is little in nature to compare with the grim corpses it leaves behind. Among them, a dense ball of neutrons the size of a city.
You form an object that we call a neutron star, which is something that has the mass of our Sun, but a radius of only about 6 miles or so. That is a very compact object. Every centimeter cubed of that mass has a mass of 100 million tons.
The mass of Mount Everest crammed into the space of a marble. Because of its intense gravity, a neutron star is a perfect sphere with a surface like polished metal.
It's like ordinary matter where there are electrons and so on orbiting around nuclei, but with all the electrons sort of squashed into the nuclei and the particles up close together. So something that we think of as incredibly dense, like lead, is really mostly empty space. And if you squish all the empty space out of it and get the nuclei right up next to each other, that's something that has the density of a neutron star.
You can find neutron stars in places like this, the Crab Nebula. Scientists combed this vast gas cloud, the remnant of a supernova that exploded 1,000 years ago. Deep within, at its heart, they detected radio signals pulsing, betraying an unknown presence.
When these were discovered by a graduate student in England in the 1960s, the supervisor thought that they should not announce the discovery for a few months, partly in order to check that it was a genuine astronomical object, but also because of the possibility that this might be an alien signal. And in fact, the code name for the object in the early days was LGM, to stand for Little Green Men.
Alien it was not, but strange it was. Now scientists are using the Hubble Space Telescope to zero in on the neutron star, the one in the center. It is sending out waves of radiation that have etched circular patterns in the surrounding gas. Yet, as intriguing as a neutron star may be, it does not compare with the sheer power of its terrible cousin. In the deep reaches of space, nature has created a monster, the black hole. Back in the 18th century, French astronomer Pierre Laplace speculated that if a star were large enough, its immense gravity would prevent even light from escaping it. 2 centuries later, Albert Einstein revived speculation in these so-called dark stars. But even he dismissed the idea as a monstrosity beyond the laws of nature. What once seemed without reason, today defines the frontiers of science. Astronomers now feel confident that black holes exist, that when a large star explodes, enough matter can collapse into its core that it literally exits the known universe.
If the mass of that core is larger than about 3 times the mass of our sun, nothing at the end can stop the final collapse. Gravity wins the final battle and the thing collapses to form a black hole.
Black holes. Welcome to the darkest reaches of space. The cutting edge of science. And the far-out fringe of popular culture. For this journey into the unknown, it's one way only.
Well, it maybe sounds like science fiction. You know that there are tides, for example, on Earth caused by the moon. Where the sea is closest to the moon, it is being drawn farther up, so you get a tide, for example. Now, the same thing would happen if you have an object falling into a black hole, say. The only thing is that because the gravitational force there is so large, the tide will be enormous, so that things will be eventually start to be torn to pieces. In fact, that tidal force increases to infinity by the time you fall into the black hole. So at first, larger objects will be torn, but then smaller. Eventually, even on the atomic scale, atoms will be torn apart, and then nuclei of atoms will be torn apart, even on that small scale. So all matter, in fact, will lose the identity as we know it. And by the time you really fall into the black hole, in fact, we don't even have the right physics to describe everything that will happen.
From our vantage on Earth, we define our universe by what we can see and know. But black holes have defied discovery. After all, how can we see an object that emits no light? Recently, though, scientists fashioned a new tool to aid their search. In 1991, the Compton Gamma Ray Observatory was launched to monitor high-energy radiation that rockets back and forth across the universe. 3 years later, it picked up a sudden eruption in the constellation Scorpius. Astronomers around the world zeroed in on the source. A network of radio telescopes stretching from the Caribbean to Hawaii recorded a rare specter. This is the object that came into view. Matter glows as it rushes into its dense core. This inward motion is so violent that jets of intense radiation shoot outward. Teams in 8 countries have trained their most advanced technology on it, trying to prove that it is in fact a black hole. High in the Andes Mountains, in the heart of Chile, astronomer Charles Bailyn is leading the search. Bailyn was the first astronomer to pinpoint the eruption's exact location. He is returning to study it again, to confirm once and for all that it is a black hole.
Okay, Luis, let's make this slew.
There have been many tantalizing glimpses, but no one has ever definitively sighted a black hole within our galaxy. If ever there was a chance,
okay,
this is
so
it.
Are we guiding?
Yes.
Looming within the dense star fields of our Milky Way, 10,000 light years away, this is the most spectacular object of its kind. They can see it because it's not alone. A normal star circles the object in a dance of death. Gas from the star flows into the black hole through a disk, while jets of radiation shoot from its poles. So powerful is the black hole's gravity that the companion star's shape is being distorted and squashed as it makes its orbit.
But that one definitely has promise, don't you think?
Bailyn and his team can't view the object directly, but they can study its companion.
If you remember, in Alice in Wonderland, there is the Cheshire Cat. The Cheshire Cat disappears from view and only leaves its smile behind to be seen. Black holes have this property. They disappear from the eye, but they leave their smile behind. They leave their gravitational force behind. And it is by that that we then see them and are able to infer their properties.
And then where's the bright star? Is this it?
To prove that his subject is a black hole, Bailyn must measure its mass.
Okay. It looks a little...
The only way he can do that is by studying the effect of its gravity on the companion.
Just finished 204. Is that the last?
For with its every movement, the star reveals the nature of the object that shadows it.
And now it's...
Right?
Okay, I see
Okay.
it. It's this.
And now
Yeah?
a look.
So here's the star right where the cross is. And that star is different from all these other stars. All these other stars are perfectly ordinary stars, just like the sun. And this thing here is a double star with a black hole eating its companion. And that's what we're going to be watching for the whole rest of the night here.
A handful of numbers. Some morsels of data. In a scientist's deliberations, one of the strangest phenomena in nature is slowly coming to light. Here is a computer image of what it might look like as light and radiation are swallowed by a black hole. In this galactic trash compactor, whole stars are crushed down to a size too small to measure. This is a realm gravity has cut off from the rest of the universe. As Bailyn concludes his vigil of 5 painstaking nights, he can scarcely comprehend what he has witnessed. Now, as he heads home, he can almost definitively say the Scorpius object is a black hole, 7 times the mass of our sun.
What happens inside the event horizon of a black hole is essentially unanswerable in scientific terms, because we are talking about matter falling out of the universe. And so you come right up against the edge of what science can tell you about the universe and what it can't. And I think that that boundary is where philosophy and religion come into contact with science. And that's an exciting thing for me.
There may in fact be millions of black holes lurking in our galaxy alone. but they are by no means the ultimate showcase for gravity's power. There is something far greater. A monster black hole called a quasar. There is one in the heart of the M87 galaxy, 50 million light years from Earth. The quasar itself is dark indeed, but gas and stars swirling into it glow brightly before they are swallowed forever. Astronomers clocked the speed of the gas in M87 and used that to measure the quasar's mass at more than 2 billion times that of our Sun. In the most distant corners of the universe, quasars formed at the centers of very young galaxies at the moment of their birth, or when two infant galaxies collided. In time, as the galaxies matured and the quasars consumed their fuel, they grew dim, but the abyss remains. Today, it is believed that quasars loom at the hearts of most galaxies, including our own Milky Way. Gas and stars continue to swirl into their dark cores. Astronomers using the Hubble Space Telescope came up with this image, the evidence, they believe, of an immense quasar. A black hole so gigantic it swallowed an entire galaxy. The vast lane of dust across its middle is all that's left of the galaxy. Its fiery grave lies deep within. No one knows just how massive this black hole now is. And if by chance two black holes meet, the terrible violence can scarcely be imagined. Scientists recently traced a source of high-energy radiation to what may have been a collision of black holes. It was perhaps the biggest explosion since the beginning of time. It may look small in this image, but it's incredibly far away, nearly 12 billion light years. In this computer simulation, we can see the results of such a collision. As the two black holes smash together and merge, the extraordinary impact sends violent ripples of matter and energy, and some believe even gravity waves, pulsating outward.
There are two reasons why black holes are important. One is because it's increasingly obvious that they play a major role in shaping the universe. But there's a deeper reason, I think, why they're important. The black hole conceals something which is very profound, which is often given the word singularity. This is like an edge or a boundary to space-time. It's a point where space and time, so to speak, come to an end.
Is this point the end of everything we know? Or is it the beginning of something else? Some scientists have theorized that black holes may in fact contain passageways to other places, other times, tunnels to different parts of the universe, or maybe another universe entirely. So far, it's all in the realm of science fiction. And yet there are so many things in the cosmos that we cannot see directly, even with our most powerful telescopes, that we know must be there. In fact, fully 90% of the universe is unseen and unidentified. Astronomers call it simply dark matter. Mysterious particles, burned out stars, or black holes. Whatever it is, dark matter is out there. Like a black hole, dark matter can only be detected by the influence of its gravity. Astronomers have, for example, measured the speed galaxies move within clusters, and found that the gravity pulling them along is simply too great for the amount of matter we can see. So too, spiral galaxies, such as our own, seem to be surrounded by vast, dark halos of matter that cause them to rotate faster than they ever would by themselves. The unseen universe has in fact shaped everything we know and can see. As we peer farther and farther into space, the discoveries and the mysteries only seem to grow. Our technology is now taking us far beyond our world and into a vast assemblage of 50 billion galaxies. We can now venture to places so distant they define the very limits of time and space. And so we begin the last and most incredible leg of our journey, to the edge of the universe. How do you measure the span of the universe? How far does it extend? And what, if anything, lies beyond its furthest edge? Even as our telescopes transport us deep into the cosmos, we are haunted by its seemingly endless depths. At the beginning of the 20th century, as astronomers looked into the dense star fields of our galaxy, they imagined they were seeing the whole of the universe. The Milky Way is in fact truly vast. It is a huge rotating disk of 100 billion stars. So large that a spaceship traveling at the speed of light, 670 million miles an hour, would still take 70,000 years to cross it. Amid all the gas and stars swirling around it, the Earth is a tiny outpost, nestled to one side. Not even the scientist Albert Einstein could imagine a greater span than this. In those days, our galaxy was seen as the limit, fixed and eternal. But this vision was soon to be shattered. In 1917, after more than a decade of construction, a powerful new telescope opened on a summit above Pasadena, California. It was called the Hooker Telescope, and it was hailed as a technological marvel. With a 100-inch mirror, it was by far the largest telescope ever built.
A 100 years ago, there was a feeling that if you built a bigger telescope, then you'd see further and it would just be more of the same. What happened with the 100-inch telescope is that it was a lot more than just more of the same. In fact, it was a fundamental reappraisal of the nature of the universe.
Many scientists came to use the new telescope. Among them, a young astronomer fresh from service in World War I. Edwin Hubble was interested in nebulas, a mysterious class of cloud-like objects. He turned his sights on the brightest of these, in the constellation Andromeda.
Hubble was able to discover stars in Andromeda that he could see were very much like stars in our own galaxy. And at that point, everything clicked into place. He got the scale, he could see that it was far away, it was big. There was no way that it was a little piece of our own Milky Way.
Hubble's breakthrough discovery was that there are other galaxies out there, that the universe is far larger than we had ever dared to imagine. But he didn't stop there. He analyzed more distant galaxies and found that when viewed through highly sensitive instruments, their light skews slightly to the red. This red shift is the Doppler effect, like the sound of a train whistle that changes pitch as it speeds past. The redder a galaxy's light, the farther it is, and the faster it's moving away from us. The universe Hubble found is immense, and it's rushing apart in all directions. It was Albert Einstein who confirmed the importance of Hubble's discovery when few scientists understood what it meant. In 1931, Einstein conceded that his own view of the universe was wrong, that Edwin Hubble had revolutionized astronomy with his concept of an expanding universe. News traveled fast, all the way to Hubble's hometown paper, and his fame only grew. 70 years later, the Space Telescope would be named in his honor.
In my mind, there's no doubt that Hubble's discovery that the universe is expanding was the most important scientific discovery of this century. And the reason is that without an expanding universe, it's impossible to make sense of the idea that the universe has a finite age, that it came into being a finite time in the past.
This discovery had a profound consequence. If the universe is getting larger, we can make a movie, a cosmic movie, and we can run it backwards. It would look very comical. All the galaxies would be getting closer together. And we can see that the expansion of the universe implies that there was a first moment, a Big Bang.
The long history of the universe, all matter, all energy, all time and space, can be traced back to this one explosive event, a great blast that set everything in motion. This computer simulation shows how gravity then drew the primordial gas into stars and galaxies over billions of years of time. The idea of the Big Bang launched the modern science of cosmology. Like Hubble before them, astronomers today place galaxies in time and space by measuring how far their light is shifted to the red. To understand the sheer size of the universe, they are working to translate these redshift readings to actual distances. Now, a new generation of cosmic map makers is using these readings to chart the size and layout of the universe, one glimpse at a time. One of those leading the research is astronomer Robert Kirshner.
It's going to be a good night tonight. We're going to get something done. We're going to find out how big the universe is. We're going to find out what shape it is. We're going to find out what kind of shape we're in. It's going to be fun. Just hope the equipment works. I always worry about the equipment.
Kirshner has come to the mountains of Arizona to establish a standard for cosmic distances, like the scale on a map that says 1 inch equals 1 mile. He's here to study what may be an ideal mileage marker.
All right, this is going to be supernova 1996, number 13, and it's going to be record number 42 on the disk.
He's looking for the cosmos' great beacons, supernovas.
We can see these things. They really exist. A single star becomes as bright as a billion stars, and that means you can see these things in distant galaxies. The whole star explodes suddenly, and you get a violent explosion, a nuclear explosion, in which the nuclear fuel, this carbon and oxygen, burns very, very rapidly in a kind of burning flame.
The flare of a supernova provides a singular chance to measure distances. Kirshner can calculate how bright this type of supernova should be. So the dimmer it appears from Earth, the farther away it is.
This is a picture that was taken while supernova 1994D was still bright. And so this is the supernova. It's a star in that galaxy that exploded. These things are so bright you can see them out halfway across the universe. That star isn't there anymore. And the light from it came to us, and we saw it a couple of years ago.
Once a distance scale is finally in hand, it can be applied to a much larger project, to actually create a detailed map of the universe. It was long assumed that the Big Bang created a sprawl of galaxies spread uniformly across space. But some researchers speculated that it might have a more complex structure. One such scientist is Margaret Geller.
Here's a nice
case.
You can ask lots of questions in science that you can't answer, either because the technology isn't there or because you just haven't defined it well enough. So if you ask, what does the universe look like? The universe is huge. So what are you going to do? I mean, you have to figure out how to map a little piece of it wisely chosen so that it will tell you something in answer to a very precisely defined question. It's hard to imagine.
That question, for Geller and her colleagues, was whether a narrow slice of the universe could reveal a pattern that is replicated on the largest of scales.
We mapped the distribution of galaxies in this first slice of the universe, not expecting to find pattern, because the prejudice was the pattern wasn't there. And when we plotted the data, we saw this pattern, which has become very famous. It's known as the stick man. So here you can see that there's a very striking pattern. There are large empty regions where there are very few galaxies, and these regions are 150 million light years across. But most of the galaxies are in thin structures which surround or nearly surround these empty regions.
As shown in this 3D display, Geller's first wedge extended roughly 700 million light years into space. It contained 1,000 galaxies. They skirt the perimeter of vast empty spaces, which she compares to bubbles. But was the pattern in Geller's slice merely a fluke? She set her sights even farther afield. Now, after years of work, more than 7 times the galaxies have been plotted over a wider area. This is what they look like. Expansive sheets of matter that encircle enormous voids. In the coming years, Geller has even more ambitious plans for cosmic mapping.
So this is about the size of the bright region of the galaxy.
That's right.
It's amazing. Gives you some idea.
She plans to do it using this instrument attached to the base of a telescope.
So the robots grab these.
It has 300 fiber optic sensors maneuvered by a pair of robotic arms. Working together, they'll zero in on thousands of galaxies a night, 100,000 a year. The robots, light on their feet, are nicknamed Fred and Ginger.
We'll pretend to be a hectospec robot.
Yeah.
You can be Ginger. I'll be Fred.
Okay. Now, a lot less graceful than Ginger here. I can barely reach this thing.
Geller believes that with technology advancing at its present rate, new generations of astronomers will have mapped the entire visible universe by the end of the next century. While Geller searches for patterns, others are trying to understand something even more basic: how the universe got its shape in the first place. Cosmologists are using supercomputers to envision the sequence of events. This simulation shows how gravity slowly but surely amplified tiny ripples in the energy of the Big Bang and shaped them into a vast web. Stars formed out of patches of gas. They drew together into galaxies. While the universe as a whole expanded, gravity held these evolving star systems in clusters. Some merged or were swallowed by others. To this day, violent duels continue to erupt between galaxies. As they draw near to each other, their immense gravity sets them on a collision course. Very few stars actually touch when two galaxies cross, because each has so much empty space within. Still, the pull of gravity takes its toll, leaving vast trails of scattered stars and gas to mark the encounter. In the aftermath, whole new galaxies are created. Even today, our own galaxy is swallowing up several smaller ones. Billions of years from now, it will collide with our neighbor, the Andromeda Galaxy. Peering across the universe, we are literally reading its history. Because it takes light time to travel, the image it carries is old indeed. And so, amazingly enough, as we gaze out into space, we are actually seeing the past.
As we look out in space, we look back in time. And today, with large telescopes on the ground and with Space Telescope, we can look at galaxies as they were 5 billion, even 10 billion years ago. Galaxies which are very young. And we can see, in fact, we can measure from the ground how galaxies were distributed. So the historical record is there for us to observe.
Amid all of its early accomplishments, the true forte of the Hubble Space Telescope has been its ability to capture visions of galaxies deep in the cosmos, billions of light years away, when the universe was far younger than it is today.
These giant telescopes, they are the only true time machines that human beings have. It is as though you were a historian and could put your eye to a telescope and actually see Hannibal crossing the Alps and all those elephants trotting along. We are actually seeing the universe and the things in it behaving as they did billions of years ago.
The Hubble Space Telescope has looked some 12 billion years into the past. There, galaxies have blotchy, distorted shapes. They are pocked with bright blue regions, places where stars by the millions are being born.
One of the most exciting things about these really distant galaxies is that they look quite different from nearby galaxies. They look very disturbed, very irregular. And then there are all these little specks, tiny specks and blobs that don't look anything like galaxies nearby. Those are probably the little bits and pieces, the little building blocks, the little galactic Lego pieces out of which galaxies were forming at a very early time.
Today, astronomers are using Hubble to extend the limits of what we can see out toward the very beginning of space and time. Mark Dickinson studies the origins of galaxies.
It's a great time to be an astronomer because you have new tools like the Hubble Space Telescope to study extremely faint objects which can't really be probed in any other way.
Took us to the airport.
Dickinson is part of an historic venture known as the Hubble Deep Field. The project will zero in on a tiny patch of sky near the Big Dipper. To the eye, it's no larger than a grain of sand held at arm's length. To most ground-based telescopes, the target area appears utterly void of galaxies or stars.
The idea of this project is to go as deep and faint as the telescope can be pushed to go and see the faintest galaxies. Those don't even show up in individual exposures for the most part. They're so faint that there's not enough light for them to record an adequate signal on one exposure. But this is one of 50 or so that we'll be taking through, say, this one particular filter over the course of 10 days.
They're counting on this venture to shed light on how the universe and its galaxies changed from the earliest times.
Yes, but it has no nucleus.
The question is, how deep in the universe can Hubble go? How far away? How far back in time? Scientists now believe the beginning of time was a moment about 15 billion years ago.
Now we can build bigger and bigger telescopes and see even farther out into space. And the limits of how far we can see galaxies now are about 10 or maybe 14 billion light years. This is assuming that the universe as a whole is about 15 billion years old. So the farthest we could see is 15 billion years, because that's all the time that light has had to travel. And that's the edge of our visible patch. It's called our horizon.
Astronomers from around the world are waiting with bated breath to see exactly what the Hubble Deep Field will reveal. They have come to a gathering of the American Astronomical Society, where for the first time the results will be presented to the world. In recent years, this event has brought a series of extraordinary revelations, but this one is unprecedented. Unveiled here, for the first time, the deepest image ever, the distant frontiers of time and space.
This is a large blow-up of it, done by a photographic lab, in which you see a very small region of the sky, 10 days of exposures, and you can see a myriad of galaxies.
The Hubble Deep Field is all the astronomers had hoped it would be. In a single picture, clear images of galaxies stretching fully 90% of the way back to the Big Bang. But as detailed as the picture is, its twisted shapes bring a jumble of cosmic question marks. Which of these galaxies astronomers want to know are nearby? Which shine from the limits of the visible universe? And what milestones in galaxy formation do their shapes reveal?
The statistics, the sheer numbers are impressive, but by itself that's not really enough. We can count the galaxies in this image and say, my God, there's a lot of them, but we don't know what they are. We need to understand what these galaxies are. We need to understand how far away they are, what their properties are, before we learn anything about galaxy evolution from a picture like this.
Astronomers will use the Hubble Deep Field as a guide for many new studies. One group of astronomers at Hawaii's Mauna Kea volcano is preparing to use the Hubble findings to pinpoint the most distant galaxies in our universe. They'll use one of the largest and most advanced telescopes on Earth, the Keck Observatory.
Probably 5 minutes. Okay.
Sandy Faber leads the team.
So you're gonna...
My own personal hope for the Hubble Deep Field is to identify the moment of the beginning of galaxy formation. What were the first proto-galaxies like? How big were they? How did the stars form in them? We're looking back to an era when the universe and the galaxies in it were really quite different from the ones we see today. But not totally different. We can see a relationship. These are infant galaxies and adolescent galaxies compared to our own mature galaxy today.
Faber and her team are looking for galaxies 10 to 15 billion light years away. Their targets appear in the deep field as tiny blue lights shining faintly among the larger, brighter galaxies. The Keck telescope is over 30 feet wide, one of the largest precision mirrors in the world. As sophisticated as it has rarely been pushed this far.
Each of these galaxies is 100 million times fainter than you can see with your naked eye. And they're hard even for this big telescope.
At last, Keck captures its first flickers of success. The spectral barcodes on the screen hardly seem as impressive as Hubble's pictures, but to the trained eye, they're nothing short of sensational. They show just how far away these galaxies
There's a
are.
really nice continuum in that object there. Here, you can also see one here. Because see, we saw something.
Yeah, exactly.
That's
That's
it.
real.
That's it.
All right.
Keck's instruments spell out the good news.
Don't be sad.
Faber and her team have recorded no fewer than 3 new far-off galaxies.
We've discovered a couple of new, really very distant galaxies in the Hubble Deep Field, which means that we're looking back maybe 12, 13, 14 billion years. So those are among the top record holders. That's what we were really after in that field, was more like that.
More than just a record of the distant universe, the deep field has become a wellspring of new information. From this patch of galaxies, astronomers can estimate the number of galaxies in our visible universe at 50 billion strong. They have also discovered that 90% of all stars were born by the time the universe was 1/10 its current age. And in another deep image, Hubble pinpointed the earliest known galaxy cluster. Here are 6 out of 18 tiny galaxies that are so close they will probably merge into one. Yet the more we learn, the more questions arise. What lies beyond even these distant worlds? Is that all there is? Or might there be other universes out there? Our own lives are simply too short to witness the grand transformations of the cosmos. As we probe these distant reaches of space, we may yet discover how it came to be what it is. And in the end, we may find that the immensity of this expanding universe is not terrifying at all.
As we discover more and more, and the universe seemingly gets larger and larger, more complex, vaster, there's a tendency perhaps to think that humans' role in this diminishes with time. But for me anyway, it's like learning my world better. I feel larger the more I understand. I don't understand the purpose of it all at this point, but at least I begin to understand my place in it.
Year by year, decade by decade, that place becomes more defined, more intriguing. Perhaps one day we will make the most surprising discovery of all. Among all the worlds we have yet to see, perhaps we will find one that also harbors life, other beings like us, staring out across the cosmos.
Well, I had one of my most amazing experiences as an astronomer looking at the Milky Way in the southern hemisphere. It was glowing, brilliant stars in the foreground, these massive dust clouds. I thought of all the other civilizations that might be floating in it at the same time. And I had a vision of one great galactic community. And I felt myself to be a citizen, not of Santa Cruz or the United States or Earth, but a citizen of the galaxy for the first time. And of course, I had to wonder whether or not we would ever fly around it and meet up with all of these other civilizations.
And so we end our journey to unravel the mysteries of deep space, inspired by the wonders we've discovered along the way. How stars die, how new ones are born in the explosive flash of a supernova, how worlds are created in a haze of gas and dust and ripped apart in the fierce abyss of a black hole. The sad beauty of a white dwarf, the chilling violence of a quasar. New planets, new solar systems like our own, perhaps even the discovery that we are not alone. And so our voyage is actually just beginning. It is a voyage we bequeath to our children and to all those who follow. For night by night, the stars overhead reach out to us across the darkness, calling us to venture ever deeper, to explore the wonders of a far frontier, the mysteries of deep space.
Funding for this program was made possible by the Corporation for Public Broadcasting and by the annual financial support of viewers like you.